charge. It's what allows our stuff to do things. And since we all know, playing with some circles again, you all know what that means. We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper-rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper-rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. Yes, I'm back. I apologize. I guess I was gonna be Planck week. Totally failed that. I was doing other stuff and things. But we're gonna continue Planck week. It happened to be separated out. So what the heck am I talking about? Why the heck am I showing these circles and stuff? All right, real quick overview. Again, this is according to the physics monastery, or Dad's minimal arena, the model of it. I like to call it the HF8 model. Thanks, Jen. But what we got here? All right, we got 5-dimensional ingredients: time, space, charge, which we're on today, mass, and temperature. Basically, those correspond to the little circly thingies in here. All right, so let's go in here. Okay, so your inner, some may say the minimal turtle of time, is literally time itself. Okay, got rotations, break and scale symmetry. What do we got? Space. Oh, gets a little bit bigger here, let's say. All right, that's kind of cool. Now we're on the third. What is the third one? Basically, the third was over here. Yeah. Okay. Yeah. Charge. Yeah. No. Okay. Time. No, that's space. That's space. This is charge. All right. Pardon. All right. Since we got that there, what are we talking about here? Basically, charge is when you start to hit the actual external thing, because the Planck constants, you have two that are minimums, time and space. I don't know. I think we colloquially refer to them as space-time. But next we have, charge. Again, it's what allows our things to do stuff. So we seem to be quite well. This is how this is being brought to you right now, to the best of my awareness. Then you have mass. Oh, look, mass, and then temperature. Our realm of the minimal arena. Okay, this probably makes no sense to anyone else, so I'll show the other things that we actually have to show here, because we said there's going to be a geometric derivation. So we're essentially looking for a closed form of the actual magnitude of the charge. Okay, and again, this is going to be conjecture. This is going to be conjecture, because basically, in order to help validate this, you need a model that makes sense, that has predictive power. And again, this model has 2 more confirmed predictions in string theory so far. The muon G2 results, which is basically really got my attention, and apparently once they redefined SI, the classical electron radius. And then again, for both those things, more beautiful things were found. Science is amazing. Okay, let's bring up our window here. One of the most reliable sources I have, which I may actually have disagreements with in the thumbnail a little bit, but again, we're going based upon the best data we have. Our friend Wolfram Alpha. We type in blank charge, we got that. Oh, we got Q sub p there. All right, that's cool. It's defined as 2 times the square root of pi. Pi seems to always pop up. Imagine my shock. Times the square root of c, which is the speed of light. E naught, which is the electric constant. And then h bar, which is reduced Planck's constant. Seems to be a very simple thing with some constants there. Cool. Comes out to be 1.8. Okay, we're looking for the actual unit. 1.87554638 coulombs. Cool. Alrighty then. We go over to our friend Wikipedia here. This is interesting, because normally in the Planck units, these are the Planck units. We consider this Planck charge, but depending on how the mass, length, and time regarding an additional unit for temperature to be redundant, they add an additional unit for electric charge so that either the Coulomb or the vacuum permittivity, E naught, is normalized to 1. Oh, so that's how we're figuring this stuff out. Okay. Thus, depending on the author's choice, the charge unit is given by, this is the one that we're looking for here, at least this number. The charge Planck is the square root of 4 pi times E naught times H. Basically that whole thing, except you just put the square root and you put a 4 pi in there instead of 2 and the square root of pi. It makes it prettier. At least it's easier for me to understand. Why? We tend to live in what appears to be a three-dimensional space-time, if you would. Yeah, 4 pi is the surface of a sphere. Seems to pop up a lot. Who doesn't like pi? But we multiply that by the electric constant times reduce Planck's constant, so we don't need those extra pi's in there. That's extra 2 pi. And then we see the speed of light, basically in a vacuum, and that we take the square root of that. What's this number here? What's this number here? 1.875546 times 10 to the negative 18 coulombs, or approximately 11.7 elementary charges. That's a charge of an electron. Technically, or a proton, too. The electron we just characterized it as negative. Ben, you took a shot in the dark. You had a 50-50 chance. Apparently, he got it wrong. Again, probably doesn't make a difference. Does it? I don't know. Okay. Go to our friend Wolfram Alpha. Again, this is found in 44. I didn't like the... I hate the shilling thing, even if it is a recent. Oh God, I forgot to link that video. All right, it's back in the other one. I'll throw us on a playlist. But okay, what's the equation we're looking for? This crazy, not so monstrous thing here. Got some cool things in equivalence. Let's see. So the claim is we're going to set it equal to the number of derangements, because that's the claim. The magnitude of that 10 to the power that we have there, in this case, 10 to the negative 18. We're basically saying you could arrange this 18 different ways to charge mechanics. Okay. So what's a very basic form to be coherent to line this up? 2 times 3, which is technically plus or minus 0, because the other one was plus minus 1, and then I think plus 1, then minus 1. 2 times 3, which is squared, gives us 18. All right. So, oh yeah. Let's just go through it. So it's 5 over the y stress constant times the, I think it's, times the square root of 7, which in the model is B, blue B. And then again, the main things are basically red N is 5-dimensional ingredients. And then 7 is the break and scale symmetry, because basically every circular magnitude you break into 7 circles. It's an interesting thing. Just if you're going to have equal size circles, symmetry is important. I'm just saying. Then we multiply that by the cubed root of 3. 3 is also a cool number. And then we set it, we multiply it by E, which is the base of natural logarithms. We raise it to what we're looking for, which we're going to claim is the magnitude of the Planck charge. We combine it with that number of derangements there. And again, that's a claim. But welcome, Whitechapel. Good to see you, Papa. It's I was totally looking for an excuse to use the Goku thing. So my Planck charge, well, if we've been ripping off Dragon Ball thumbnails again, attribution in the link doobly-doo below. Hey, made sense to me. Well, we'll see where else we get. I think the last one may have Jiren in it. It's gonna make a lot of sense. Again, probably wrong. Most things are wrong. If it's not wrong, I think it's pretty neat. All right, we continue on. So when we throw all this stuff in here, what does this give us? Oh, look, 5e. One may interpret that as 5-dimensional ingredients, if you would. That was a base of natural logarithms, and we're going to search for the magnitude there. The magnitude when we set it equal to 18 different ways to permutate things. And then we get that 3 by 3, and then that, and the y stress constant. What is the y stress constant, you say? We go to our friend Math World here, brought to us by Wolfram.com. The Y stress constant is defined as the value of sigma, and then it's either 1 or 1, comma, I, the imaginary unit. Oh, and divide by 2. Wait. So 1 or 1I, you divide by 2. It's not like there's any symmetry to charge or anything we know about. Where sigma is Z or W1 or W2. I think those are the omega constants. Omega, he says, is a Y stress sigma function with half periods of W1 and W2. So, yep, omega 2 constant. Cool. Amazingly, it has the closed form of 1/2 of sigma, that 1 or 1I, is set equal to, look, raised to 5/4. Oh, we got the square root of pi in there. We saw that earlier. We got e raised to pi, and that's divided by 8. I'm not saying it has anything to do with a domino tiling constant. We'll get there eventually. That's all divided by gamma to the second, multiplied by 1/4. Okay, we got 2 of something. We got 5. We got 5-dimensional ingredients, and it's almost like we're quadranting. I think that's the term we started using. Quadranting. Now, some may say a sphere, a circle. Depends on how you want to experience the flavors. We got the square root of pi, which I think that was. Oh yeah, you got the square root of pi there. Oh look, we got a 2. And again, I am not a professionally trained physicist nor mathematician. I am a dude on the internet. But I've been blessed enough to speak with some really smart folks, including some that may be watching now or temporally in the future. We continue our dive. Oh, we're at. Oh, all right. We got E, and we got pi there. Again, who doesn't like pi? And we got. Oh. Oh, wait. No, I think that's actually a lemon skate. Yeah. Yeah, that looks like a lemon skate there, I think. Whatever. But gamma 2, it basically gives us this number here. Or that gamma z is the gamma function, of course. Okay? Go back over here. Look at that cool stuff. Oh, look. Oh, we brought gamma up top there. The gamma function's appearing there. Because we're taking out the y stress constant. Oh, look. The e to the x. Huh. Lemniscate. That's a figure 8 thing, or the infinity symbol. It's almost like there's something going on. Huh. Let's take a look. What's that give us? That's a very interesting solution to that right there. Setting equal to that, I wasn't able to make anything of it. Okay, cool. Gives us this number here. What's the number according to Wolfram Alpha? This number differentiates. Okay, 1.87, 1.87, 554, 554, 6038. Oh, it's a 5. It's a 5. Oh, look, that's a 9 right there. So we may ask, what's our level of confidence? Because, well, from Alpha, I take, oh, it's also 17 Rydberg charges. Very interesting. I thought there's like 17 elementary particles. Meh. All right, let's actually reload. Give this more digits. If not, well, we will go to our friend Wikipedia because they don't list this. You usually got charge divided by, they have it comes in electrons in NIST. So that's time divided by current. So basically it already has time hooked up to it, some may say. All right. 1.875546. 1.87, what was it again? 0.875546. 5540. If that happens to be, and I think that may have been updated since the redefine of SI, if that is a 6, and we have that with a high degree of confidence based upon our best measurements to date, I don't know. That would probably fall within error bars. I'm just saying that, again, just me, but that looks to be a geometric derivation of the Planck charge. And again, we're making assumptions here. We are making assumptions. Again, we're saying that this is the magnitude. This is the magnitude in relation to us setting this function equal to 18. Basically, we take our system and we set it up with this particular structure 18 ways of permutating or deranging, some may say. Yeah, we've got that. And again, it's negative. We are making our assumptions here. Again, this is hyperbolic, or at least it's a system that's based on hyperbolicity. So we are making assumptions that at least that magnitude, the way it's set up, gives us this number here. And we also got that, so we got our pi and everything in our eyes. Oh, the logs, I have to show you the logs. Jen stressed this to me. I'm seeing what she's saying. All right. The other way you could express it is x equals the log of 18, my stress constant divided by 5, plus the log of 3 divided by 3 and the log of 7 divided by. I don't know. I just love it. It's very pretty. Now, I'm not saying that a universe is a computer. I will make the claim that our universe is Turing complete. Why? Because we can. It also means that, at least as humanity goes, we play our cards right. Might be like World of Warcraft. Maybe we can play it forever. Ooh, that brings me back. Memories. But, yeah, that's all we got for right now. Thank you all for watching. Take care of yourselves, everyone. It's a wacky and wild world out there, but I think there's some cool stuff right on the horizon. Take care of yourselves, everyone. Peace. I hit the